Hi, everybody. Good morning. Happy Tuesday. Yesterday, you guys took a look at lessons 9.1 and 9.2, which were all about quadratic functions and quadratic graphs. Today, we are looking at solving quadratic equations. Okay, now this might sound like super easy, but there are a few different methods and it's kind of like a distinct process. So I just want to make sure that I go into depth about all three methods and you can choose which is best for you. So your objective for today is that you can solve quadratic equations. So in your notebook, here's your title. Get ready to take some meticulous notes. And let me just talk to you really quick. When we're solving normal equations, it looks like this. 2x plus 5 equals 10. Okay, you guys could solve, that's supposed to be equals, sorry. You guys could very quickly subtract 5 to the other side and divide by 2. That's a normal equation. But today, we're going to talk about how to solve a quadratic equation, meaning that your x has a variable of 2 as the exponent, okay? And it might look something like this. So not as easy to solve, and there's 3 different methods to do so. So let's get started. The standard form of a quadratic equation, which we looked at this a lot yesterday, is ax squared plus bx plus c equals 0. For it to be an equation, it has to have an equal sign and set equal to 0. In this standard form of a quadratic, a cannot be 0. That's talking about our leading coefficient right here. This guy cannot be 0. And if you're wondering why, well, if I made this 0, then anything that x turns out to be, whether it's 3, 4, 5, when you multiply those together, it'll stay as 0. And then this term would essentially go away. If you just have bx plus c equals 0, that's just a regular equation. That's like the 2x plus 5 equals 10, and it's no longer a quadratic equation. So for this to stay a quadratic, a cannot be 0. Okay, so that's just standard form there. There are 3 methods for solving equations, and I'm going to talk to you about when you should use each one and how to use each one. Okay, so here are your 3 methods. The first one is graphing. Graphing is a good way when you actually are already given a graph. Okay, this isn't something where you'd be like, oh, let me just go quickly graph that quadratic, because we saw yesterday that that's a lot. It takes a lot of steps. So graphing is great when you already are given a graph. Okay. Square roots method. This is good for when you can detect a perfect square. So if you see like you've got 16, 25, 36, 100, 125, no, sorry, that's a perfect cube, 144, or when there is no x term. Okay, this is important. A lot of kids overlook this part. So if you see a quadratic and it's just like this, like x squared, hold on one second. If it's like x squared plus 16 equals 0, notice how there's no x term. There's no like 5x or minus 3x or whatever. It's just x squared and a constant. This is your clue that you're going to want to solve using the square roots method. You also see that you've got a perfect square here with 16, so that's another clue for you. The third and final way for today, I'm going to teach you a new way on Thursday, is factoring. This is good for very quick solving, and it's good for you guys who are good mental mathematicians. This is my favorite way. Okay, so we got graphing, square roots, and factoring. Let's start with method number 1, or let's just talk plainly about the solutions of quadratic equations. There can be 1, 2, or no real solutions for a quadratic. So when you solve it, you might get 1 solution, you might get 2 solutions, or you might get no solutions. When we talk about the solutions of quadratic equations, we're talking about the roots of the equation or the zeros of the function. This is new vocabulary for you. So when you solve a quadratic function, you could call those solutions roots of the equation. You could also call them zeros of the function, okay? Because when we look at this graphing method, the solution would be here and here. Okay, that's where they hit the x-axis, and that's kind of leading us into our method number 1. So method number 1 is graphing. Here are 3 different quadratics, okay? So you've got x squared minus 1, x squared equals 0, x squared plus 1 equals 0, and they're already graphed for you. If I asked you what the solutions were for A, first of all, you're going to tell me that it has 2 solutions, right here and right here. It's wherever it crosses the x-axis, and I can tell that this is -1 and +1, so that would be known as plus minus 1. Or you could physically type out like +1 and -1. If I was looking at this graph here, this would only have 1 solution. And I see that it only hits the x-axis as 0. So the one solution for this guy would just be 0. Okay, this last one, I'm sure you can guess what it's going to be. It doesn't hit the x-axis at all. So this is going to have no real number solutions. So just to recap with graphing, this is the method you want to use when you're given a graph and you're looking for where your parabola crosses the x-axis. If it hits it twice, you'll obviously have two solutions. Okay, and in this case, it'd be -1 and +1, and we'll show that as plus minus 1 for a more concise mathematical answer. If it hits your x-axis one time, okay, you've got one solution, it's wherever it crosses. If it doesn't hit your x-axis at all, then you have no real solutions, and that's it. All right, now on to method number 2. This is solving using square roots. So there's two times when you would see something like this and you're like, ooh, I need to solve that using the square root method. The first one is when you detect a perfect square. Okay, so if you see you've got 4, 16, 25, 36, 49, you're like, I'll probably solve that using the square root method. Or if you look at a quadratic equation and you don't see an x term here. Okay, notice that it's just 3x squared minus 75 equals 0. So that's your clue to use square roots. What you're going to do is essentially you're just going based on instinct on solving for x. So if I want to get x by itself, I know the first thing that I'm going to have to do is see this minus 75 here. We're going to add that to the other side to start isolating your variable. So we're adding that to both sides, and I would have 3x squared equals 75. Now, what's your next instinct on isolating this x here? How do we get this by itself? Well, if x is being multiplied by 3, and that's our coefficient, we're going to divide both sides by 3, which would give us x squared equals, what's 75 divided by 3? 25. And then the last step to get x by itself, if you see a number squared, the inverse operation is to take the square root. And the square root of 25 is 5, but remember, it's plus minus 5 because if you do positive 5 times positive 5, that gives you 25, or negative 5 times negative 5 also equals 25. So when you do the square root method, you'll get plus minus and then whatever that square root is. Let me show you another example. If I give you x squared minus 16 equals 0, and I want you to solve this quadratic equation, first of all, you're noticing two things. You've got a perfect square, and you don't see just a plain x term. That's your clue to use the square root method. So you can go ahead and start by isolating x here. We want this by itself. You see how you have minus 16? We're going to add that to both sides, and I'm just going to do little quotations here so you know I'm doing the same thing. When you do that, you're given x squared equals 16. The only way to isolate x from that exponent of 2 is to take the square root, and then you know that x will be equal to plus minus 4 because positive 4 works as a solution and negative 4. And that's it for the square root method. Pretty simple. Okay, last method, and this is the most critical for your algebraic labs here. When we are solving by factoring, we're looking at the zero product property. That is just fancy words for, okay, here, look at the example that you've got. If I showed you that you have x plus 3 and x plus 2 as your quantities here, that's like if you factored a trinomial and you got these two binomials and they were set equal to 0, you can set each one equal to 0 to solve for x. So I did x plus 3 equals 0 and x plus 2 equals 0. And then you just solve it like that. So essentially what's going to happen is you'll be given a trinomial, which is in the form of a quadratic equation. You'll factor it, you'll set both binomials equal to 0, and then you'll solve. So let's pretend that I already factored the trinomial, and here's what I got. 4t plus 1, and then t minus 2 equals 0. Let's start by setting our first quantity equal to 0 to solve for t. So I've got 4t plus 1 equals 0. I'll subtract 1 on both sides to get t by itself, and then I divide both sides by 4, and I've got t is equal to negative 1/4. And that'll happen a lot when you guys are doing this. You might get a fraction, you might get a decimal, it's not a big deal. Then over here, I'm going to take this t minus 2 and set that equal to 0. Well, t minus 2 equals 0. To isolate t, we're just going to add 2 to the other side, and we get t is equal to 2. So those would be our two solutions of this equation here. Now, it's not always going to be that easy for you. You're going to have to go through the steps of factoring to solve. So here's what it's going to look like. If this quadratic can be factored, you can use the zero product property to factor and solve. Now, in a few days, you'll see ones that can't be factored, and I'll show you a different method of solving, but today it can. So go through your steps like normal to factor. I know that to get my two binomials, I'm going to need two numbers that multiply to C and add up to B. So what are two numbers that multiply to 15 but add up to 8? And I bet you guys can probably come up with it pretty quick in your heads that it's going to be 3 and 5. So when I factor this guy, it'll be x plus 3, x plus 5, all of that equal to 0. Now to physically solve for x, you just need to set each quantity here in parentheses equal to 0. So I've got x plus 3 equals 0, x plus 5 equals 0. To solve for x, I'm going to subtract 3 from both sides, and I just get x is equal to negative 3. And then over here, I just get x is equal to negative 5. Now, oftentimes, you'll see your answers written as solutions like this. Or it could look like this. They've got the fancy brackets here. The order of the solutions does not matter, but usually you'll see them in brackets with the numbers together. Okay, let's do two more, and then we are done for the day. All right, if I asked you to solve this quadratic equation, okay, you see that it's in a trinomial, okay, a trinomial format. You know that you can factor to get two quantities in parentheses. So I know that I'm going to need two numbers that multiply to a negative 17, but add up to a positive 16. Well, as soon as you see that numbers are multiplying to a negative, you know that one will be negative and one will be positive. And I know that the only factors of 17, because its prime is just 17 and 1. If it has to add up to a positive 16, I know that it's going to be a positive 17 and a negative 1. So when I write that in factored form, I've got x plus 17, x minus 1, all equal to 0. Then you just set both of your parentheses, both of your quantities equal to 0. So I've got x minus 1 equals 0 and x plus 17 equals 0. To isolate x here, I'm going to add 1 to the other side, and I got x equals 1. Then I'm going to subtract 17 to the other side here, and I got a negative 17. And again, your solutions can look like this, or it can look like this. And that's it. Okay, let's do one example for when you're given a quadratic equation and you're going to factor it, but your leading coefficient is greater than 1. So if I ask you to solve this by factoring, you've got 2x squared minus 11x equals negative 12. The first thing you need to notice is that this isn't set equal to 0 right now, and that's a problem. It has to be set equal to 0. That's why I gave you this little reminder to make sure it's in standard form first. To put it into standard form, okay, we want 0 over here. To move over a negative 12, we're going to add that to both sides. So I've got plus 12, and I've got plus 12. So then I would have 2x squared, still minus 11x, plus 12, all equal to 0. Oh my gosh. Now you're ready to factor. It's in standard form, it's set equal to 0. So because my leading coefficient is 2 and it's greater than 1, I'm going to need two factors that multiply to AC and add up to B. I know B is negative 11, and then A times C, 2 times 12, is 24. Hopefully in your head, you're like, all right, if I've got two factors that multiply to a positive but add up and their quantity stays as a negative, these guys are both going to have to be negative. And I know right away it's not going to be 4 and 6. It's not going to be 12 and 2. It's not going to be 24 and 1. It's going to be negative 8, and it's going to be negative 3. Because when you add these together, you get a sum of negative 11. When you multiply them, you get positive 24. Okay, yay for us. So here it is in standard form, written out nicely. Now, when you factor, remember that you're splitting up this negative 11x and writing it as a sum of negative 8x and then minus 3x. That came from right here in my blue terms. The next step in factoring is to get that GCF out of your first two terms and then your second two terms. Okay, so when we're thinking about factoring out my GCF, we always group them by the first two and then by the second two here. So here's what I would have. I know if I've got 2x squared and 8x, my GCF will be 2x, and then all I'd multiply is by x minus 4, because 2x times x is 2x squared, And then 2x times negative 4 is negative 8x. Over here, my GCF is going to be a negative 3, and then I'd multiply again by x and then minus 4 here. And that makes sense because when you do negative 3 times negative 4, that gives you a positive 12. Now, before we can get through and solve this quadratic, we need to group and look at the colors that we used to do so. We're going to group our GCFs, the 2x minus 3, and then this common quantity, we'll rewrite that once. So now you've got your sets of binomials that you can set each one equal to 0. So if I solve this green one here, I'm going to have 2x minus 3 equals 0. To isolate x, I want to add this negative 3 to the other side, and then I've got 2x equals 3. We're going to divide both sides by 2, okay, to get x by itself. And your final answer will be x is equal to 3 over 2 or 1.5. Both work. For this guy here, this one's much easier. I'm going to have x minus 4 equals 0. To isolate x, I'm going to add this 4 to the other side, and then I just get x equals 4. So in terms of writing your answers, it could look like this. It could be 3 over 2, 4. 4. Or it could be 1.5, 4. Or you could switch the order for each of those. All right, so before I give you your assignment, let's just recap really quick. When we are solving equations that are quadratic, they have an exponent of 2 and they're always set equal to 0. If they're not set equal to 0, you need to change that so that it is. There are 3 methods for solving. Graphing, which is good when you're just physically given the graph and you're asked to identify what the solutions are, or you're asked to identify where the roots of the equation or the zeros of the equation are. Square roots, that method is good when there isn't a single x term or when you detect a perfect square. And factoring, that's good for all of us who are really quick with factoring, or if you can tell right away that the equation will be easy to factor. There are 3 options for number of solutions. You can have 1 solution, 2 solutions, or no real solutions. And I think that is it. Your assignment for today is the Solving Quadratic Equations Schoology check. Make sure that you take it 2 times for your highest score, and then we'll practice this skill tomorrow. I think that's it for today. Have a wonderful day, wonderful Tuesday, and enjoy your week. Thank you.